second law of motion is commonly referred to as the law of acceleration. For acceleration, we will use the equation F sub net is equal to m times a, which means the net force is equal to mass times acceleration. For the units of net force, we will use newtons. For the units of mass, we will use kilograms. And for the units of acceleration, we will use meters per second squared. For this law, we can also use F sub W is equal to m times g, where g is the force of gravity and F sub W is the force of weight. In this equation, the units we will use is newtons for force of weight. Mass, we will still use kilograms. And for G, we will use 9.8 meters per second squared.
Okay, so when we let the ball roll down the ramp, the force that was acting upon the ball was the force of gravity. So for this, we would use the force of weight equation, which is this one right here. So let's see what we have. We have the mass of the volleyball, which is 0.292 kilograms, and we have the acceleration due to gravity, which is 9.8 meters per second squared. When we plug this into our equation, we multiply the mass times the gravity, and we get our force of weight to be 2.9 newtons. The force acting upon the basketball is also gravity. So we would use this same equation and we would be finding the force of weight. What we have is the mass of 0.046 kilograms, and we have acceleration due to gravity of 9.8 meters per second squared. When we plug this in, we will multiply the mass times the gravity, acceleration due to gravity. F of W is equal to 0.45 newtons. The greater the mass equals the less acceleration because it's indirectly proportional, and vice versa. The greater the mass, the greater the force, because these two objects are directly proportional, and this is also vice versa. Since the mass of the volleyball is greater than the mass of the basketball, it will take a greater force to push down the volleyball.